All right, so there we go. All right, so today, last section before your quiz. Your quiz is going to be on Tuesday, so Monday will be a review day. Okay. This last section is about what's known as a compound inequality. Okay. If you talk about a compound word or you talk about a compound fracture, that would be painful. You're talking about having more than one. Okay. So here we're going to talk about a compound inequality, meaning we're going to have more than one inequality in the problem. Essentially, what we're going to do is we're going to give more than one restriction to the problem. So maybe, x could have been just less than 5. Now x is going to be less than 5, and then there's going to be another piece after that as well. There's two ways we can do this. We can either use the word and or the word or. Okay, so forget the mathematical context for a second. Just think about the words and or. What do they offer you? If somebody comes to you and uses the word and, or if somebody comes to you and uses the word or, what's the difference? Which one has an option? Or has an option, and does not have an option. And requires you must complete both of the tasks that are laid out. Good, bad, or indifferent, right? Or means you get a choice. Okay, so that's going to be kind of our distinguishing factor today. Whether the requirements are of both, mathematically we use the word an intersection. Okay, so think about like a road intersection. Okay, they share a common space in the middle of that that's called the intersection. It's typically where your accidents take place, unfortunately, right? Because it's a shared area and they're both sharing it at the same time. That's where the problems come into play. In an or situation, we're talking about a union where we're going to bring two ideas together. Okay, so we'll look at those two and then we'll kind of flip it around and look at it from the other direction. We're not going to mess with this because we spent some time with your homework. So our goals today to deal with compound inequalities that use the word and then how do they look graphically? And then secondly, compound inequalities with the word or, and then them graphically. So what is a compound inequality? And then those are the two options that we're going to get into. So hopefully we can, what's up? Do we use a graph all year? No, not all year. But with inequalities, yes, all the time. And we just came out of graphing linear equations. So it feels like, yes, it does feel that way right now. But no, not all year. All right. All right, so if you read this here, the pH level of herbal essence is somewhere between 6 and 6.5. All right, think about that for a second. The pH of herbal essence shampoo is between 6 and 6.5. If you had to graph what that looks like, how would you graph it? Logan, what would you do? Okay. Okay. Okay, so you're thinking an open circle at 6 pointing which way? Right or left? To the right. And then an open circle at 6.5 pointing which way? So to the left. So essentially those two things coming towards each other. Okay. Or you could just connect them. Okay. That idea? Yeah. Okay. So if you want to be between those values, really what you got going on is you got something here going that way, and you got something here going that way. Would you consider this thought to be an and or an or thought? You agree or disagree? I heard you twice. Why? Oh, maybe Tyler. He doesn't ever talk. Huh? Stop. Yes, he did. Okay. Whatever. You're fine. Focus. Okay. Define this statement to your head for a second. Do both requirements have to be fulfilled here? Does it have to be greater than 6 and also less than 6.5? Or does it only have to be one of those things? It has to be both, right? Well, let's think about this. The pH scale goes all the way up to, do you know? Okay, 14. Good job. All right. If the pH of this shampoo was a 9, does that work in this scenario? You would, is 9 between 6 and 6.5? No. But if we use the word or in here, then how many of these two requirements are we actually requiring to be true? If we use the word or, just one. And is 9 bigger than 6? Or less than 6.5? And you would say, yeah, it's bigger than 6, right? Which means that's why this word can't be there. We're going to need that word in between there because it's going to have to require both of those things to take place. All right. And so, like a couple of you guys had mentioned, if both of these things have to happen, then really what we're talking about is being somewhere in between those two values. All right. As poorly as I draw, do you know what this is? It's a field goal post. And if you're going to make it, where does it have to be? In between, not just inside of one of them or inside the other one. It's got to be in between both of them in order to go in. All right. But, so when you're looking at this, you have to kind of think of that the same way. When it says the words, is in between something, well, then that means that both of these requirements are necessary. Okay. And so when you graph inequalities, there are a couple options of how they can look. Okay. So if you look at this here, when we use the word and, we will expect to cover the area in between two values. When we use the word or, we will expect that we're looking for one option or the other. Does that make sense? Now, there's obviously a rare situation where this doesn't take place. Okay. So think for a second. If I said to you, find me a value that is greater than 8 and a value that is less than 4. What's that? That's not how math works? Oh, okay. Good. If you were to graph the way this looked, what would it look like? Like, just think to yourself, what would the lines be doing? They'd be going like that, right? And so things that typically work away from each other can be thought of not as and statements, but or statements. When the word and is between something that looks like an or, you said, hey, man, that's not possible, right? I can't do that. What mathematically would we say about something that cannot be completed? It could be thought of as an empty set. It could be thought of as having no solution, okay? Things that are impossible to do. So when it's supposed to look like one, but it looks like the other. It would, right? Because you want to be less than 4, that'd be moving to your left. You want to be greater than 8, that'd be moving to your right. In an and situation, I need to find some place they share in common, something that they both have. Well, they don't have anything in common. Okay? Now, the other situation would be something like this. Be greater than 2 or less than 5. Those would go which direction? They would go towards each other. But you're only requiring how many of them to be true? Just one. So it looks like an and, but it's written as an or. Is it no solution? Give me a number, any number you want. Anything you want. 7. That was really, really wild. Isn't this bigger than, won't this eventually get there? Is 7, is it bigger than 2? Yeah. So give me another number. Perfect. Well, that's bigger than 2, right? So I'd get it with this one over here. Give me a number. Sure. It's covered by this one, right? Okay. Covered by x is less than 5, right? Because it goes eventually down there to the left. Sure. This one, covered by 2. What, huh? Sure. It doesn't get covered by this one, but it gets covered by x is greater than 2, right? Is there literally a number that you could come up with that I can't cover with one of these two statements? Great, then we get it twice. You know what I mean? So in an or situation, when you're only requiring one of them to be true, but yet your picture would look like this, that one going this way, and this one over here going that way, won't eventually one of them cover everything? So mathematically, if I can cover any possible option out there, we would say all answers, all solutions, infinite solutions, whatever you want. Okay? So when it's supposed to look like an and, but it looks like an or, there's a problem. Right? When it's supposed to look like an or, but it looks like an and, or when it's supposed to look like an and, but it looks like an or, there's a problem. It's either everything or nothing. We got to figure out which one of those we're talking about. But like 99% of the time, it'll do what we think it's supposed to do. Okay, so you just got to kind of be mindful that maybe they won't always graph like what you think they'll graph like. Okay, so we're just going to look at a couple, all right, to try to kind of illustrate this idea for us today. Does anybody need this? Okay, all right. So, have you all seen a symbol that looks like this before? What's that called? A Venn diagram, right? And Venn diagrams are supposed to do what?
Separate and
okay. Yeah, right. So something that they share versus something that they don't. In this particular case, this overlapping area is trying to highlight for me what information. Yeah, but what are they? Look at what's listed there and tell me, what are they trying to do? What are they trying to do? What are the values that they're trying to encapsulate here? Use actual numbers. What are we actually referring to here? Perfect. And where you're using the word and or the word or here? Both circles are sharing this common space together. So the word would be and, right? I'm looking for things that are bigger than 0, but are also less than 10. That's why these two things overlap each other. All right. So in a graphical sense, that's kind of how you would think about it, as them sharing space together. In an algebraic sense, it kind of looks like that. Now that looks weird, okay? But you see two inequality symbols inside of there, which means there's something that these two share in common. What is it that these two share in common? No? Jack, you got an idea? It is an and, yeah. But what do they share? There's actually two problems inside of this problem. Does anybody know what the first problem is? You take a guess? Perfect. So if you have not yet, you should have this on your paper. Okay. This isn't, maybe you do something like this in your notes, like split your paper in half. We're going to look at an and inequality on the left-hand side, and over on the right-hand side, we're going to look at an or inequality, like how do they look? You know what I mean? So you can just kind of have the difference between the two, so to speak. This would be an example of an and. So, I mean, if I'm going to claim this as example 1 over here, I would say -5 is less than or equal to 2x plus 1, which is less than 3. What's that? Oh, okay. So here's what I'm going to do. This right there is my first inequality. So I'm actually going to pull that out of there because that's something that I'll need to solve. Now, a compound inequality using an and statement actually shares something in common. So what is the part that the second one has that's exactly the same as the first one? What part do they overlap? Exactly. So in the second inequality, it starts with that exact same overlapping piece. They both share the same portion. So my second one is going to be 2x plus 1 is less than 3. Okay. If you thought about those circles, they each have the same 2x plus 1 overlapped inside of them. Okay. So this is an example then of an and compound inequality. So at this point, I'm going to do what? I'm going to solve them. So take a minute, whatever, 2 minutes, and solve them. Like, what's it going to look like if I solve them? Now, because they shared the variable is what they both had, we're going to solve them the same way. Like, we'll end up moving the same parts in both of them. I think it may be a decent idea for you to kind of mark your notes the way that you see it up there. Almost like putting boxes around the pieces that I'm going to claim. You know, like there's number 1. And then if you're using the same color, I mean, that's not a big deal, right? But then the second one, and then I have those 2 that are being pulled out of the same problem. What's up? Okay, so now the next section is how do I graph? What's that picture look like? Very good. All right, move the 1, divided by 2. I get my first statement. And then in the second one, I'll do the exact same things. I'm going to minus the 1, and then I'm going to divide by 2, and it's going to say x is less than 1. Okay. Because it's an and statement, graphically speaking, it should look like what on a number line? What should it look like? Give me 1 second. What should it look like? Good. It should be 2 inequalities coming towards each other. Is what it should be. So if it's not, then we'll have to figure out what the heck's going on, but that's what it should look like. What's your question? You will put them together in your final answer? I got you. All right. So let's graph this first. All right. So 0, 1, 2, 3. We don't need a huge number line. Okay. Whichever one's easier for you to graph, I guess graph that one first. Maybe it's the blue one. X is less than 1, so you're at 1 coming to the left. If you read the red one from the variable, it says that X is what? From the variable, it says it is greater than or equal to, so that's moving in which direction? That way, to the right. Okay, so we're at -3 and we're heading to the right. So did it do what I thought it was going to do? So the answer there is yes, it did, right? That's 2 things that came together. So the area that they share in common, that's the solution area. Okay, now Olivia's question was, do I need to put them back together? You're not wrong to say that your answers are x is greater than or equal to -3 and x is less than 1, but you won't see it written that way. You'll see them written as one joined statement. Very good. Okay, so what it's going to look like is essentially it's going to look like this graph right here, except with the values back in its place. So on the left-hand side, -3, on the right-hand side, 1, and my shared variable that's in both of them in the middle. And then the correct symbols, obviously, that go in that place. But look at the blue one. It's right there. X is less than 1. Look at the red one. If you read it from the variable, it says x is greater than or equal to -3. So it's those 2 things linked back together. Okay. It is weird. Yeah, and if you know, obviously you can't do this, but if I thought about bringing this and laying it on top of there, there's that one. And if I thought about bringing this one over here and laying it on top of it, you know, it's there as well. So they do kind of they come back together because unfortunately they were together when we started. We pulled them apart to solve them, and we'll put them back together when we're done. All right. Try this one. See what you can come up with. It's the only other one we're going to do in this section. This is it's an and because they're joined together. We'll look at an or here in 1 second. Ors are much easier. Yeah, you always like ors because they give you choice, huh? So this is still an and, but after you write it, think, what am I going to like draw my first box around? What is the first inequality? Give it a shot. What do you think? Give a little bit more in both of them. So we're going to go all the way to the +5, but we're going to include that entire chunk. That's my first one. Okay. Aiden, what's up? There you go. So my second one then is going to be the overlapped section, essentially all the way to the end. Okay. So, you know, what does that one look like? And then over here, what does this one look like? Now here, because you have variables on both sides, we would not necessarily solve them the same way. And the last one we did because the variable was the shared piece. But here, you solve those however you want. Variables got to go to one side, constants got to go to the other. That's not going to be a 6. If that's a 2n, so then you have to divide by 2, so n would be less than 3, not 6. You see where I'm at with that?
Or you can't have 2. Like
Okay,
that.
but look what you did. You moved
Yeah.
the variable over here, so your n is on this side.
Yeah.
But now your n's over there.
Oh. So.
Right at this point right here,
Yeah.
you have to move the 5. Because you already have your n's on that side.
Mm-hmm.
So that would say that n is over here is greater than -4 and -5 is -9. So there's your first answer.
Okay.
Okay. You can decide, guys, to move your variables either way. Just remember, whichever way you decide to move your variable, if it leaves you with a negative coefficient, then you'll have to change your sign. So just kind of keep that good. So graph it, and then you're done. Yes, awesome. So what does the picture look like for that graphically? So 1 and 2. Okay, so you divide right here by -2. Because you divided by a negative, what do you have to do with that sign? You got to flip it. That up there originally, that's an 11. You wrote it as a 1. Well, you have it as 11 here. Very good. All right, so join your like terms. I'm going to kind of combine these at the same time. That'll leave me with -9 is less than or equal to n. So there's 1. And then for the blue one, I'll do the same. Minus the n. Here, minus the 5. I get 2n is less than 6, so n is less than 3. Okay. Now, I solved those two different directions because that's what kept n positive. Okay, for me. If you would have decided to move the 3n over to the left-hand side, now you got a -1. Now you got to divide off the negative. Now you got to change the sign. You're not wrong. I mean, obviously, as long as you do all those things, you're not wrong. I think it's easier if you keep it positive. So again, that's an and. They should come together. If they don't, then we got to figure out, did I make a mistake, number one, or is this one of those situations where I'm requiring something to happen that can't happen, and then maybe it's a no solution idea. But you get into forgetting to flip signs, then you could end up finding out that you actually made the mistake, not the problem. So be careful there. If we do this, I got to get to, probably have to count by twos. Just side note, counting by even numbers when all your answers are odd, that's real genius work right there too. So wow, that would have made way more sense. Count by threes. I'll keep that in the mental bank. I'll use that next time. Credit to Jack Downs. Okay, there we go. All right, so n has to be greater than or equal to -9. So -9, man, threes would have made way more sense. Moving to the right, and then n has to be less than 3. So less than 3, moving to the left. So if I'd learned how to read, that's got to have an equal to on it. What's that? Don't be like that. Could you imagine being at home right now watching this and having to go, man, what in the heavens is he like? Where's the side conversation? Hey, listen, I get about 11 views a day, okay? Don't judge me. Yeah, 11 on a good day. That'd be weird. All right. So the last thing, you never do. The last thing is writing these two together. So remember, match it right off your picture. So -9 there, 3 on the right, your variable of n in the middle, and then figure out how your signs need to go. But this one already looks correct. It's a less than, and then this one would be a, well, it depends on which way you're reading it from. If you're reading it from the number, it's a less than or equal to. If you're reading it from the variable, it's a greater than or equal to. Okay. Public service announcement, these symbols will always go the same way. If they don't, one of two things, you're wrong, or there's something going on with the problem that makes it do that fashion. Okay. All right. So that's an intersection. They share something in common. The other option is an or. Okay, or what's mathematically known as a union. In a union, you're bringing things together. They don't already currently share something in common. Okay, so these two circles don't overlap because they do not share anything in common. So it says you could be less than 0 or you can be greater than 10. You can't be both of those things, right? You can't be less than 0 and greater than 10. So they're not going to share anything in common. They're not going to overlap. Their pictures are not going to go together. Their pictures actually are going to do what? They're going to go away from each other. So if they don't, then something's going on. Now, these are way easier to solve because look at how they have to be written. They have to include the word or in between them. Okay? Yes. You have to write the word or because they don't share anything in common. They're both not required to be there. It is a pick 'em and choose 'em kind of situation, right? Either this one or this one. It is easier because they're already separated. They're two individual problems. Okay, they're being held together by the restriction of, hey, one works or the other works. But now these obviously are very simple because they're both little one-step ones. It wouldn't matter if they were bigger. They still have to be separated from each other. So to solve them, right, I mean, one option is it's less than or equal to 5. Or the other option, okay, is that x is greater than 7. They have to start separate from each other. Think about the Venn diagram. The Venn diagrams don't overlap, so they can't be written together. Now, when you graph them, though, then less than or equal to 5, greater than 7. Okay. So ORs are much simpler to put together because the one on the left said that it had an equal to, so that it's allowed to be that number. This one says it's got to be greater than 7, so it's not allowed to be 7, just the things that are bigger than 7. All right. Now, if I flip it around, which one is which? Kyler, give me one. I know. Well, I don't know. Yeah. The right one is an OR, which means then I should be able to write it. Okay. What are the requirements here? Give me one of the options. And the variable can be whatever you want. So if we want it to be a K, or if we want it to be an X or an N or an A or whatever we want. So give me what does this one over here on the right hand side say? Sure. A is what? Greater than 0. Okay. Well, it just says it's greater than 0. It's moving off to the right. What does this one over here say? That A is what? Now it's colored in, so less than, or, okay, so less than or equal to, and the number it's at is -8. Okay. Done. Can't write them together. Can't write it as one thing. Doesn't exist as one thing. They are two separate statements. This one over here, where they're joined together, is an example of, Jack, an and statement. So to do that, just think how we did the last one. Think about writing it inside of that box. What numbers at the beginning, what numbers at the end. Okay, what numbers, Tyler, is at the beginning of this? And at the end of it? And what variable is going to go in the middle? Sure. Now I need two inequality symbols. So I essentially need to fulfill this one over here. What would make that requirement there take true? A less than. So in between the x and a 5 would be a less than, right? That one's done. Now over here at the -2, it's also an open circle, but this one's pointing to the right. So from the variable, it would be a greater than, but from the number, it would be a less than. So it would look like that. Okay. Remember my public service announcement. They'll be the same. Now, one of them may have an equal to because it's colored in, or they might both be colored in, or they both are open. But if it's truly an and, they're both going to be written the same way. Well, yes. Why will they always be opposite each other? Because the numbers are going away from each other. Right? So the bigger one will be on the right, moving to the right. The smaller one will be on the left, moving to the left. Even if they're both positive numbers or both negative numbers, the one on the right-hand side over here is going to be the bigger value, and the one on the left-hand side would be the smaller value. Okay? All right? So sometime before I see you on Monday, you have a form that's more concerned with the picture and the answer portion than it is like you solving it. We've solved a lot of inequalities, okay? So that's kind of what we're looking at before I see you next.